Good morning, everyone. Today we are going to discuss about tri-cellular model of atmospheric circulation. Now, the global distribution of Earth's insolation is not same all over the world. Some portion are energy deficit and some portion are energy surplus. Mainly the equatorial region and the subtropical region considered as energy surplus region. On the other hand, in polar region, both North Pole and South Pole are considered as energy deficit. Okay, that's why there is a need for heat redistribution. The Earth receives intense solar energy at the equator and very little at the poles. Without a mechanism to balance this thermal inequality, the tropics would be unimaginably hot and the poles lethally cold. The atmosphere is that mechanism. Now, there are three cellular model, tri-cellular model. This is the blueprint for global balance of atmospheric temperature. Okay, the tri-cellular model is a framework describing the global patterns of air movement. It divides the atmosphere in each hemisphere into three major circulation cells. Together, these cells play a crucial role for redistributing heat and moisture around the globe, shaping our weather and climate. Now, this is the Hadley cell between equator and 30°, both south and north latitude. Then in between 30° to 60° north and south latitude, Ferrel Cell is situated. And the polar cell is situated between 60° and 90° north and south latitude. Okay, Hadley cell, Ferrel cell and polar cell. Now, first of all, the Hadley cell, the tropical heat engine. Okay, main mechanism is, this is the equatorial region. It is a low pressure area, low pressure zone, and in here the subtropical high pressure is situated, high pressure. And always remember that air move from high pressure to low pressure. That's why this high pressure zone to this low pressure zone, there is a circulation of air. Okay, this ring is known as Hadley cell. Located near the equator, the Hadley cell is driven by powerful solar radiation. Warm, moist air rises, cools, and condenses. This process forms massive clouds and leads to heavy precipitation in tropical regions. Okay, the result, the persistent rainfall needed to sustain the world's last tropical rainforest. That's why in the equatorial region there are various number of rainforests found, and there are various type of tropical rainforest and evergreen rainforest because of the heavy rainfall in this region. Heavy precipitation due to the this movement, Hadley cell. From rainforest to desert, the descending runs. On the other hand, in the 30° north and south latitude, this is the area of descending dry air and is a high pressure zone, as we know. After rising at the equator, the air moves poleward at high altitudes. It cools and becomes denser and causing it to sink around 30° latitude. Okay, it sinks around 30° latitude. As the air descends, it warms and dries, inhibiting cloud formation. Okay, it inhibited cloud formation. That's why the stable air conditions that create the world's greatest subtropical deserts. Because of this mechanism, in the 30° latitude, there are some various deserts located in this region. Okay. The surface connection, trade winds and the Coriolis effect. Okay, this is equatorial low pressure area and subtropical high pressure zone, and air always moves from high pressure to low pressure, and this trade winds moves towards the right. Okay, towards the right because of Earth's rotation, that is Coriolis effect. The air descending at 30° creates a high pressure zone as the surface air flows back towards the equatorial low pressure zone. Okay, this is the process, and it is deflected by Earth's rotation towards the right. Okay, the Coriolis effect, the deflection of moving objects like wind when they are viewed in a rotating reference frame. In the northern hemisphere, it deflects objects to the right, in the southern hemisphere to the left. Now, second, the Ferrel cell. The main mechanism is it's happened between 30° north and south latitude and 60° north and south latitude. And in this region, the air is high. that means high pressure region, and this is low pressure region. And always remember that high pressure air move from high pressure to low pressure. This is the part of this warm air and cold air, again warm air, again cold air. Okay, this is the process. The Ferrel cell is located between the Hadley and polar cells. This is the Hadley cell and this is the polar cells. It involves complex interaction between warm air rising from the subtropics. This is the subtropic regions in warm air rising from the subtropics and cold air sinking from the higher latitudes. This class of air masses is a primary source of energy for weather systems. And the impact of this Ferrel cell is there are variable winds and weather patterns typically of the mid-latitudes, including powerful cyclones and fronts. That's why in this region there are various kinds of cyclones and fronts are created. Okay, now the prevailing westerlies, the main mechanism is this is subtropical high pressure region and this is subpolar low pressure region. And this from this high pressure regions which moves from towards the north towards the subpolar low pressure region and create the prevailing westerly winds. Air flowing from the subtropical high pressure zone towards the poles is deflected eastward. Okay, eastwards because of Coriolis effect, and this creates the westerly winds. These powerful and persistent winds are responsible for steering most weather systems across the mid latitudes from west to east. Lastly, the polar cell. The main mechanism is this is the polar cell. It's more like this, and this is the high pressure zone. The polar cell operates near the poles and is driven by extremely cold, dense air sinks near the poles, creating a high pressure zone. This causes the air to flow out along the surface towards the mid latitudes. And the result is the frigid, dry conditions that characterize the polar regions. Okay, this is the polar westerlies and front, polar easterlies and westerlies. Okay, this is the polar high pressure region, subpolar low. That's why air move from this direction. Coming from this direction. Polar front, the zone where warmer air from lower latitudes rises over the colder polar air. This lifting action leads to the formation of polar cyclones and precipitation and is a major feature of mid-latitude weathers. The sinking polar air flows towards the lower latitudes, getting the polar easterlies. This is the polar easterlies and deflected west by the Coriolis effect. This is deflected by west, and these are west. These are easterlies, west by Coriolis effect, where this cold air meets the warmer air moving up from the subtropics. A significant boundary is formed. Okay. Now the global engine is assembled. Okay. First of all, Hadley Cell, Ferrel Cell, and Polar Cell. Hadley Cell is situated between 0 degree to 30 degree. Then 30 degree to 60 degree Ferrel Cell is situated, and between 60 degree to 90 degree Polar Cell it occurs in border hemisphere. The equatorial low, subtropical high, subpolar low, and polar high. This is the pressure belt. The Hadley, Ferrel, and polar cells do not operate in isolation. They form a single continuous system of circulation that transfers energy across the globe, completing the loop and maintaining the Earth's thermal balance. Okay, all these three type of cells maintain the atmospheric temperature and the distribution of atmospheric temperature equally around the world. Okay, global distribution of temperature. Okay, they maintain the global distribution of temperature. Now this is the overall picture of this global pressure and wind belts. A summary view. Again, equatorial low pressure, subtropical high pressure, subpolar low, polar high, then subtropical high, subpolar low, polar high. And in this between, the northeast trade wind, then prevailing westerlies and easterlies. Then again, southeast west trade wind, prevailing westerlies and polar high. This subpolar low, subtropical high, equatorial low, subtropical high, subpolar low. Okay, this is the whole scenario. Now this model is important because heat redistribution, okay, moves thermal energy from the equator to the poles, makes the planet inhabitable. Moisture transport governs global precipitation, creating the world's rainforest and deserts. In weather systems, drives the formation and takes of major weather systems like cyclones and fronts. And climatic zones establishes the fundamental climate zones that shapes ecosystems and human societies. Okay, these three models contribute towards the global heat distribution, then transport of moisture, and control the weather systems and define climatic zones. Okay, that's all for today. If you have any doubt and query, just let me know in the comment section. Thanks for watching. Thank you.